Hello everyone, in this video I'm going to go through the AQA 2022 Combined Science Physics Paper 1 Higher Tier. This is question number 3, which is on the energy topic. A trampoline is made from a steel of material held in place by stretched springs. Figure 5 shows a child on a trampoline. So you have a child in the highest position here, and thus B is the lowest position. Position A shows the child's maximum height above the trampoline. Position B shows the lowest position reached by the child when landing on the trampoline. Describe the changes to the stores of energy of the child, springs, and the surroundings as the child moves from position A to B, as they actually go from, as they fall, essentially. So child, what's happening to the energy store? When they're on the top, they have gravitational potential energy. As they're falling down, that gravitational potential energy is actually changing to kinetic energy. So gravitational potential energy decreases and the kinetic energy increases and then decreases to 0. Right? So just before they touch the surface of the material, the kinetic energy, all the GP has been converted to kinetic energy, and then as soon as they land on the material, it becomes 0 as it's converted to elastic potential energy of the spring. So in the springs, elastic potential energy increases. And what about the surroundings? Right? Well, some of the energy is lost as thermal energy. So the internal energy store of the store of energy increases, meaning the thermal energy of the surrounding increases. Question 3.2. Now this is a 5-mark question. Calculation. When the child is in position A, each trampoline is stretched by 0.056 meters. Now that's the extension. That's the extension. The elastic potential energy of each spring. So elastic potential energy is E. When the child is at position B, the elastic potential energy of each spring increases to 8.1 joules, from 4.9 to 8.1. So that's again the elastic potential energy. Calculate the extension E of each spring when the child is at position B. Now, using the energy, the equation that links all of this is this equation. Elastic potential energy is equal to half K for the spring constant, E squared for extension squared. So if I find the spring constant using the energy and the extension at position A, then I should be able to use that spring constant value in here to work out the extension. So at A, right, 4.9 joules is equal to half is 0.5 multiplied by the spring constant multiplied by 0.056 squared. So the spring constant K is 4.9 divided by 0.5 times 0.056 squared. So 0.5 times 0.056 multiplied by 0.056, because it's a square, that gives us 1.1 568 times 10 to the power minus 3. Okay, so 4.9 divided by 4.9 divided by 1.568 to the power of 10 to the power of minus 3. Yeah, that's correct. So that's 3,125 Newton per meter. That's the spring constant. That should bring us to the halfway point. So at B, we use the spring energy, which is elastic potential energy is 8.1 there. So 8.1 equals 0.5 for the half multiplied by the spring constant as 3,125 multiplied by this extension squared. So the extension would be the square root of 8.1 divided by 0.5 times 3,125. So 3,125 times 0.5 is 1,108.1 1562.5. So 8.1 divided by 1562.5. That's square root of 5.184 times 10 to the power minus 3. So the last step, the square root of 5.184 to the power of minus 10 to the power of minus 3. That should give us 0.072. Yeah, 0.072 meters. Question 3.3. As the child bounces on the trampoline, the child does work. What is the work done by the child equal to? The work done should be the average force applied, no. The maximum force, no. The total energy store of the child, no. The total energy transferred by the child, yes. So the work done is equal to the energy transferred by the child to the springs. That brings us to the end of question 3. I will see you in question number 4.